P5 Factoring Polynomials Day 1. P represents the prerequisite chapter, which is the first chapter in our book. And our learning goal has changed now to be that you will be able to write functions in equivalent forms and graph functions with and without technology. So in this lesson, we're going to be factoring. We're going to look at different ways to factor. We're going to start with factoring a GCF. GCF stands for greatest common factor. So I'm going to go over different ways of doing the GCF. Okay, let's look at example 1A. So let's say you had 4x squared minus 8x. And usually when there are two terms, you always figure out what do they both have in common. Well, I can take out a 4x. When I say take out, it's basically like you're dividing both terms by 4x. So I would be dividing this by 4x and this by 4x. And then the part that's in parentheses is what you would have left. So the first one would be x minus 8x divided by 4x is 2. And you can always check your answer. If you distribute back and you get what you started with, that means you factored it correctly. B. Sometimes you may have three terms. And then you have to find out what is the greatest common factor of all three. Well, notice all three have an x in common. And actually, the most that they have in common is an x squared. And then they all have a common factor of 6. So I'm going to divide or factor out a 6x squared. And however many terms you have here is how many terms you should have inside your parentheses. So I'm going to divide each one by 6x squared. So the first term will now be left with x squared. The second term, if I divide those, I'm going to get negative 3x. And notice the exponents, I'm subtracting them. Because that's when you divide, you subtract the exponents. And the last term, 12x squared divided by 6x squared, will leave me with 2. And remember, because those cancel, you can always check your answer by distributing. And if you get the same polynomial that you started out with, then that means you did it right. And then the last example may be new to some of you all. But even in this form, we can figure out what do both terms have in common. So 2x plus 5, 2x plus 5. So if I divide everything by 2x plus 5, and notice whatever I'm dividing by goes on the outside, then I'm left with x squared plus 17. And that is factoring using the GCF. And when you do, in this particular case, both terms go in parentheses. Because whenever you have two terms, you need a set of parentheses. Example 2, now we're going to factor by grouping. And factoring by grouping is used when you have 4 terms. And just as its name says, you're going to group, and then you're going to group. And you're going to see what does the first group, what term does the first two have in common. So you're doing GCF again, but you're doing it in groups. So the first term has an x squared in common. So I'm going to divide both by x squared. And you're left with x plus 6. Over here, both of these terms have a negative 2 in common. And a negative divided by a negative is a positive, so you have x. Negative 12 divided by negative 2 is 6. When you get here, then you should have two terms, just like the previous example, where they have another common factor in common. And in this case, it's x plus 6. So I'm going to divide both by x plus 6. And you're left with x squared minus 2. And remember, since it's two terms, you're going to put this one in parentheses as well. And that's your final answer. Example 3, we're factoring trinomials. Trinomials mean there are three terms. And I know that your Algebra 1 teachers may have taught you different ways to factor. I'm not going to try to change the way that you learned how to factor, but if you don't understand how to factor, please let me know and I can go over it. We're going to start off with a term where the leading coefficient is 1. So remember, you're going to find two factors. When I mean factor, I mean like this. Two factors that multiply to give you 15, but add to give you 8. And of course, the x squared, we would need an x and an x. So the only two numbers that multiply to give you 15, but add to give you 8 would be 5 and 3. And they both have to be positive. And that's how you factor. And you can always FOIL. If you're ever in doubt, FOIL it out. And that should give you the trinomial that you started with. Now, our problem comes when we have a leading coefficient that is not 1. Because we can no longer use two factors of negative 3 that give you 5, because we need a 2x squared in the beginning. So a lot of students use what is called the x factor, which is fine. And if you're going to do it that way, you're going to multiply the a and the c. A and c, because when you're doing a trinomial, it's ax squared plus bx plus c. So you're trying to find two factors that multiply to give you negative 6x squared, but then they have to add to give you 5x. So this is what they have to multiply to, and then this number they have to add. And the only two that would work would be 6 and negative 1. If you want to put the x, that's fine. So usually we would just do x plus 6 and x minus 1. However, when you try to FOIL this back out, you will not get a 2x squared. So I've showed students this trick. If your leading coefficient is not 1, you're going to divide both of these by that leading coefficient, which is 2. Now, if it divides evenly, like 6 divided by 2 is 3, that's perfect. But if it doesn't, this 2 becomes your leading coefficient, or your coefficient. Now, when you FOIL, you can get a 2x squared. And if you FOIL FOIL these two factors completely, you should get 2x squared plus 5x minus 3. Now, if you were taught a different way, that's fine. You can also use your method of choice. And I'll just do one more. Okay, here again, we write our two factors. We can't just do two factors of -4 to give you 8. You have to actually take your first and your last number and multiply them together, which is -36. And we have to find two numbers that multiply to give you -36, but add to give you 5. So remember, this is multiply. This is what they have to add to. And the only numbers that would work would be 9 and -4. So remember, usually we would do x plus 9 and x minus 4. But we won't get 9x squared when we FOIL it. So what you do is you divide both of those by the leading coefficient, which is 9. And remember, one of the terms will divide evenly, or they may, won't always. And then the other one, 4/9, it can't be reduced, so this 9 goes in front. And if you FOIL it back out, it should give you 9x squared plus 5x minus 4. I keep reminding you to FOIL because that's the way we check our answers for factoring. And then if there aren't any numbers that you can find to multiply to give you that special number, that add to give you the middle one, then that's when it's prime. And that's our lesson on FOILing, or excuse me, factoring.